Okay, everybody, I'm going to see if I can do this in less than 10 minutes. We've already worked through 1 through 13, so refer back to your notes when concerning these charging and discharging of a capacitor, circuits and equations, and steady state problems. These are also in some of our homework as well. Let's look at number 13. It is asking us for low pass, high pass, band pass, and notch filter circuits. This is what they look like. This turns out to be a low pass circuit. This is a high pass circuit. This is a band pass, and this is a notch filter. So problem 14 says, what does the plot look like? And you see that it says actually a Bode plot right there. That is referring to H versus F, the magnitude of the transfer function versus frequency. So there's the low pass, there's the high pass. You remember what the notch filter looks like and the band pass. This is a band pass filter right there, and this is a notch filter right there. Alright, and so for 14, just see my graphs above. Number 15 is saying design a circuit that will remove the noise from the figure on the top of page 310. This is what it looks like, and it's a low frequency signal, but it's got some high frequency noise on the top of it. What you want to do is clean that up and make it look nice, which means removing the high frequency. When you remove the high frequency, that means that you need to have a low pass filter. So there's your low pass filter diagram as kind of a hint, but the diagram that I'm looking for is that one right there. Input here, output over there. Where did I get this from? That's right back up here. Low pass filter. It doesn't always have to be a function generator. It can just be any old signal coming in, and you're filtering out the high frequency stuff in this low pass filter. In the next problem, problem 16, it says refer to another figure at the top of page, let's see, here it is right here. Okay, so now we're talking about a complex signal that is composed of the signal you're looking for, 60 hertz hum from the electronic noise, and just some random acoustical noise, which is becoming electronic noise. You add these three things together and you get a mess. Most of the time in science you do get a lot of noise in your electronic instruments, so the key is to use filter circuits to filter them out and get back up there. How do you get these two components out? The answer is to get rid of this 60 hertz hum or noise that you have from just normal building noises from the 60 hertz AC signal coming from wall outlets. You put a notch filter in there that will block out just the 60 hertz. So you set the resonant frequency F0 to 60 hertz by cleverly picking out a capacitor and inductor value that will notch that out. Then you want to get rid of this high frequency stuff, so you put a low pass filter. What does this look like in real form instead of block diagram? It looks like this. Here is the notch filter, and I got that from right up here. So this part of it is the notch filter, and this over here is the low pass filter. So you just put them right together in series, and this one filters out 60 hertz, this one filters out high frequency noise, and you're left with just the good stuff.